ahead and put that away and take out your books. But first of all, we have a few things that we have been learning, we've been getting better at, and we want to see if we remember some of those things. So first of all, Hannah, can you explain to me the rule of multiplying exponents? What do you remember about that from yesterday?
You just add the exponent value.
You just add the exponent values. But Anna Grace, I think you might remember this. What has to be true if we want to add our exponent values? I see those wheels turning.
They have to be the same.
The same. Hannah, can you help her out?
Variable.
The same variable, that could be used because a lot of times we use letters. So you're thinking if we have x to the 4th, then if we want to be able to multiply these and add our exponents, we have to have x, right? X to the 6th, let's just say. And what do we call this when we have exponents? What is that called, Anna Grace? Starts with a B. Base. All right, because we're going to want to work on that today. We'll be needing to keep that in mind. So anytime we have exponents and we want to put them together, then we have to have the same base. If we don't have the same base, if we have x to the 4th and y to the 6th, well, we just have to leave it that way. But we can go ahead and make this x to the 10th. So you guys had that. We just were not clear on that word base. So make sure you remember that. What is, and now you said a variable, Anna Grace, which those are called variables sometimes. I think, Hannah, you said a variable because we know the x and a and z and y. Those are all variables. But what do we call those when we are talking about coefficients? What kind of coefficient is that, Anna Grace? We have two types of coefficients, and which type is that one? Are our letters.
Is that the constant, the literal?
It is the literal and it is the constant. Very good job. So the literal is our letter, and the constant, it is not the constant, because the constant is what, Hannah?
Your numerical.
It's the numerical. So the constant is the number because it's not changing, and the literal is going to be our letter. So you can sometimes remember letter with literal. So make sure we're keeping those straight when we have algebraic expressions and different things. So whenever we're adding and we have different expressions, should we ever add unlike terms, Anna Grace?
No.
We shouldn't. Why shouldn't we add unlike terms, Hannah?
You're not allowed to.
Because we're not allowed to. They're not the same. That's good. If we have oranges and apples, well, they're fruit, but we can't add those together. Those don't go in the same basket. It's the same way if we have M's and we have Y's. Those are their own things, and we can't put them together. But I have a question for you. What if we had XY and XY? Hannah, could we add those together?
Yes.
We could, because they match exactly. Okay, what if we had x squared y and xy? Can we add those together, Anna Grace?
No.
No, because they have to match exactly. Remember, I said we like to lay it over, and if it's a perfect match, then we can add or subtract them for that matter. And lastly, for our last question, this is one that we talked about way back. It's been several days. When we are looking at a polynomial, remember we have trinomials, we have binomials, and we also have monomials. What is one way that we can look at that and be able to classify it in one of those, Hannah?
I don't know.
You don't know? Anna Grace, do you want to give it a try?
Would it be the signs, the numbers?
You can look at the signs and add one, or you can look at your number of terms. So however many terms it has, then that's what it is. So if it has 3 terms, it's a trinomial. If it has 2 terms, what is it, class?
Binomial.
A binomial. And if it has 70 terms, what do we call that, Anna Grace?
A
A polynomial, because we have many terms. That's right. So we were mentioning yesterday, and we learned, and we did lots of practice with our exponents and multiplying them. And we just did an example of that up here on the sideboard, and we said that they have to have like bases. And remind me one more time, Hannah, what is it that we're doing to the exponents when we're multiplying our exponents? What are we doing with those? What's that operation?
You add them.
We are adding. Well, today we're going to look at dividing exponents. And I want you guys to start thinking something, and we're going to get it in our head and carry it forward. But we know that multiplication has an opposite. What is the opposite operation of multiplication, Anna Grace?
Would it be division?
It is division. So I want you guys just to take that opposite and put it in your head, and we will be looking at that, and we'll see some similarities of how everything is opposite with division. Go ahead and open your books up to page 124. We're on 4.8 dividing powers on page 124. So we have a problem they've given us, and it looks much like this one up here. And are you there in your book, Anna Grace?
Yes, ma'am.
Can you read me number 1? It's the bold number 1. Can you read that to the class?
To divide powers that have the same base when the dividend exponent is greater than the divisor exponent, subtract the divisor exponent from the dividend exponent and keep the same base.
Okay, those were a lot of words, a lot of dividends and divisors, but there's one thing that is in bold in your book and it stands out. Now remember, I just talked about how we have opposite with our multiplication and our division. Well, in bold print is subtract. So you guys, we remember that from yesterday, we added when we were multiplying. So today, since we're doing the opposite of multiplying, we're doing division. What is the opposite of adding, Hannah?
Subtract.
Subtracting. So today we're going to be subtracting our exponent. That's basically what that big paragraph with a dividend, a divisor, and all of those words is saying. It's saying when we are dividing powers of the same base. Now that's something else we want to keep in mind. We have to have that same base, then we're going to subtract the powers. But this isn't as simple as it was yesterday. Yesterday, we just added. There's no special case with that. You just added straight across. But we're going to get to some special cases with our dividing of exponents that we'll be looking at in just a little bit. But let's start off with this one up here. I have x to the 5th power divided by x to the 3rd power. What's another way to say x to the 3rd power, Hannah?
X cubed.
X cubed. So x to the 5th divided by x cubed. Now, make sure we have our arithmetic mechanics down. If I wrote 2, actually that's not what I wanted to say. If I wrote 4 divided by 2, and I wanted to make that a fraction, I wanted to have a number over a number, how would we write that? We've done this tons of times, but I want to make sure we get this before we start moving forward. How would I make this look like something like that, Hannah?
You have a 4 and then a dividend bar and the 2.
Okay, a 4 over the 2. So I just want us to make sure whenever we have it written out long like this, that we know how to write it. So first of all, we're going to write this in our fraction form. So how would we write this in the fraction form like this? I'm going to do it for you. We would do it just like we did here. It's the same thing, except we have letters. So it would be x to the 5th over x cubed. That's something you all have done before, and we can just know that that's what we're going to do anytime we see one that's written out in the long form. But we're going to go ahead and take a closer look at what this is really asking us to do. So we've been talking about exponents, and we know what those mean. What does x to the 5th mean, Anna Grace?
X times x times x times x times x.
Okay, so we know we have 5 x's, 1, 2, 3, 4, 5. I have a history of leaving off some letters, so if y'all see that I don't get them, I'll make sure and point that out. And then we're going to put our divisor bar, dividend bar, we're going to separate so we know what we have there, and we're going to write this. We know that x cubed can be written how, Hannah?
X times x times x.
X times x times x. So now I see some of those wheels turning, and we know what we're getting at here. We are just going to cancel like we have been canceling before. Just like when we had over here, we had 4 over 2, but we know that this cancels this, and it leaves us with 2. Well, we can do the same thing with our letters. So we're just going to cancel 1 for 1 for 1 and see what we have left over. So we're going to cancel 1 here, 1 here, 1 here, 1 here, 1 here, and then 1 here. So now we have all of those marked off, and we just have these 2 on the top. So that is going to give us x squared, and that's our answer. So we can write this out the long way every time, x, 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 and sometimes we're going to have really long ones. But remember, yesterday we added with multiplication, and we read that we subtract exponents. So if we wanted to, we could have just done 5 minus 3, which equals, class?
2.
Which equals 2, and we would have gotten x squared. Do those match? They do. So this shows us how we can do it and just make it, and make sure that we are checking our work and getting it down these first few ones. Remember, just a few things before we move on to the next one. Remember, we have to have the same base. I forgot to ask you guys that if we could even divide these because we have the same bases, but we could because we had an x and an x. And then remember, when we get our final answer, we are going to keep the same base that we had. There's no reason to change this to an a or to a b because we had an x. So let's look at this one right here, x to the 5th over y squared. We're going to go ahead and do this one, and we're going to expand it the long way. So be writing this down on your paper as I walk through it. So once again, we have y and to the 5th and y squared. The first thing I'm going to do is see what operation are we doing. We are dividing. So the next step is to see, do they have the same bases? And that'll be our second green light, and we can go ahead and do our problem. And we do have the same bases. We have y and y. So I'm going to go ahead and write this out, y, and y. 1, 2, 3, 4, 5. And then we have 2 more y's on the bottom that's being divided. So we have y and y. So that's a lot of y's. We're going to go ahead and start crossing off our y's. So I like to say, okay, I cross off 2 here because I know I have more up here. And then I'm going to cross off these 2. Or we can just go and cancel. So that leaves us 1, 2, 3, which would give us y cubed. Once we can look at this a different way. Now this isn't written out the same way, but we know that we can just go ahead and find the difference in these 2 because subtraction is the difference, if you guys remember that from way back when we learned the different parts. So it's minuend, subtrahend, difference. So we can look here and 5 minus 2 equals, class? 3. And we would have gotten y cubed. And we see that those match. So let's go ahead and do this last one before we practice a few on our own. We have x to the 7th over x cubed. What is the first thing we need to look for, Hannah, when we are doing these kind of problems?
You have the same bases.
We do have the same base, and what else do we need to look for, Anna Grace? That is right, and there's one thing we want to look at before that. Anna Grace, do you remember?
To see our operation.
To see our operation so we know if we're going to add, subtract, to see what it is that we're doing. So we are, what is our operation, Anna Grace?
Division.
It is division. So we're dividing, and you said to see if we have the same bases. Do we have the same bases? We do. Okay, so we're going to expand this out, and you guys help me make sure that I get this right. How many are going to go on this first line on the numerator, Hannah?
7.
7. Why are we putting 7?
Because you have the x to the power of 7.
X to the power of 7, and we know that that's what that means. So we have x, 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 4, 5, 6, 7. Is that right? 1, 2, 3, 4, 5, 6, 7. And then how many are we going to put in the denominator, Anna Grace?
We're going to put 3.
3, because cubed, 3. We're going to have x, x, and x. Now we're just going to do the same thing, and we're going to go through. I really love canceling because it just is like cleaning things up. So we're going to clean things up and cancel what we can. And how many does that leave us with, Hannah?
4.
4. So we have this would equal x to the 4th power. But we could have just found the difference. 7 minus 3, class? 4. And we know that our base is x to the 4th power. And they match. So we know that we did it right. Go ahead and look at our practice problems on page 125. Let's look at number 4. We already did number 1. So let's look at number 4. I want you guys to work on that one at your desk while I get the board erased. Once you are done with that, you can just put your pencil down and look this way. That was number 4. And remember, if you read the directions, it says write out these problems in long form and then solve. So make sure you're not skipping that step to write it out in long form. Okay, Hannah is done. We're just waiting on a few more to finish up. Okay, Anna Grace is done. Looks like the rest of the class is done. So, first of all, I'm going to let you guys tell me how to do this one. Get all this erased. I know that bothers people sometimes. Okay, Hannah, what was the very first thing that you did?
I noticed that it was division.
It was division. Very good. What was the second step that you looked for, Anna Grace?
I made sure that the bases were the same.
And what did you find?
They were the same.
They were the same. Does everybody agree with that? A equals A? I think so. Very good. All right. So let's go ahead and get into this. So then, Hannah, what did you do? So you found that the bases were the same and you found that it was division. What did you do?
In my numerator, I wrote out A times A times A times A times A times A.
I get that right? Yep. And then, Anna Grace, what did you do next? I'm assuming you wrote this line.
I did.
You
write
did.
that one.
You got ahead of us there.
And then then I wrote A times A times A times
So
A.
you had 5 A's?
No, just 4.
Just 4. Why did you have 4?
Because it's A to the 4th.
All right, she got it. Just making sure Anna Grace is staying with us. So the next step is, Hannah?
We're gonna cancel.
Okay, so I'm just going to start canceling and you tell me when to stop, okay?
Okay. Stop.
Okay, she said to stop. Very good. You caught me. And that left you with what was your final answer, Anna Grace?
I had A to the A squared.
A squared because we had 2 left over. And we know that 6 minus 4 is, class,
2.
is 2. And that would have also given us A squared. So you can see that all we're doing is finding the difference. So I want you guys to go ahead at your desk and work on 4 and 6 and 7. 4, 6, and 7. If I can get, yes, Anna Grace,
Can I go below my nose?
you may. If I can get Hannah to go to the board and do number 6, and then Anna Grace, when you get back, if you wouldn't mind presenting number 7 for us. Okay, this, you don't have to write this big. Make it smaller. Anna Grace, if you could scoot down, make sure you're keeping your distance, and you can erase that and write it smaller. Sure you're working diligently at your desk. Okay, so you all did number 4, 6, and 7 at your desk. So we have 6 and 7 at the board. So number 4, you should have gotten A squared. Everybody get A squared? Great job. Hannah had number 6. Go ahead and tell us what and why you did and got what you got.
My problem was x to the 9th power over x to the 6th power. So I wrote it out and had x times 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 x over x times x times x times x times x times x. And then I just canceled out one by one and I was left with x times x times x which equals x cubed.
X cubed. I would agree. Does everybody else agree with that? You had quite a long one there, Hannah. Thank you for doing that for us. You can erase that and have a seat. Anna Grace, number 7. Everyone make sure you're paying attention. Take it away.
Well, I had a to the 5th power over a cubed, and so I wrote that out as a times a times a times a times a over a times a times a times a. And then I canceled those out and was left with a squared.
A squared. I would also agree. Great job. You can erase that and have a seat. So we've pretty much got the hang of this, I think. We're just canceling and taking what we have left, taking our base, and there's our answer. But remember, I said we were going to have a special case. And so we have a very special case. I love it when we have special stipulations to what we are learning. We have number 2. Anna Grace, you read that first part for us back on page 124. Hannah, would you mind reading number 2 for us?
To divide powers that have the same base when the divisor exponent is greater than the dividend exponent, subtract the dividend exponent from the divisor exponent, and write as a fraction having a numerator of 1 and a denominator of the same base and the obtained exponent.
Great job. She just read a very big paragraph with lots of words, numerator, denominator, dividend, divisor, subtract, all of those big words. She did a great job. Thank you, Hannah. But how many of you actually know what she just read? Anna Grace is saying no. When I was looking over this before I was getting ready, I read that and I said, what? I had no idea what I was talking about, and I thought, we'll just do a few problems and see exactly what they're talking about. So if you remember all of the ones we've been doing, up to now, the ones we just did on the board, the ones we've been working on together, those have all come out with an easy way for us just to write it. So we're going to look at this one, and we're going to do the exact same thing that we've been doing this whole time. So we have x cubed divided by x to the 5th power. And I just said it. What is our operator in this, Anna Grace?
Division.
It is division. And can we go ahead and divide these, Hannah?
Yes,
Why?
we have the same base.
We have the same basis. So we're going to write this out in the long way. So I'm going to go x. But remember, if you guys can think about it, the ones we've been having have had the largest number on top. But we're going to do this just like we normally would, and we're going to have the smaller number in the numerator. So we have 3 x's, and then we're going to have 5 down here. Does everybody agree with my x's? Did I get those right? I hate it when I miscount my x's. So now we're just going to cancel, just like we have been, and I like the way Hannah did her cancellation over here, and Anna Grace did it too. You did the big long lines through it so we know what we've done. So now we've canceled. I think everybody would agree with the way I've canceled here. But our leftovers are in the bottom. So what are we going to do about that? We would go ahead and write a fraction, because these are in the bottom, and we have 2 of them. So we have x squared. But what is going to go on the top? Because we don't have anything left. All of our x's are gone. But remember, we've said in the past that if we have this, we have an understood coefficient in the front. And I saw Anna Grace nod her head. What is that understood coefficient?
It's a 1.
We have an understood 1. So even though all of these have been canceled, we have an understood little 1 over here, and he's not going anywhere. We can't get rid of him. So we would just put that 1 on top, and that's how we would write our answer. So you can see that these look different than the ones we did a few minutes ago. And also, if we wanted to just subtract these, which we haven't dealt a whole lot with negative numbers yet, we would get 3 minus 5, that equals negative 2. So we would get negative 2. And I need to get my x here first, and I need some new chalk. We would get x to the negative 2. We haven't had any of those yet. That is really odd. So anytime we have a power like this, and it's going to have the most in the bottom, we're just going to put the fraction, and we're going to have the 1 above it. So here we could just take this, if we have a negative number and you put it in the bottom like that. You put it in the denominator. So let's look at a to the 5th divided by a to the 9th power. We have a lot. This is going to be a long one. So let's go ahead and start this one. First thing, our operator is a division sign, so we know we're dividing. And we have the same basis, so we can go ahead and move forward. So I'm going to go ahead and write 5 A's. And I think I got that right. 1, 2, 3, 4, 5. And now I'm going to write 9 A's. Y'all might want to check me on this one. Sometimes I lose count. Does it look like I have my 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now we're going to cancel. We're just going to put our slashes through. And we have 4 left over, but they're in the bottom. So we're going to do the same thing, and we put that number in our denominator. We have a to the 4th, and we remember that we have our understood 1 over here. So it's 1 over a to the 4th. So we can still do this without writing it out in this big long form. I know you're scared that I'm going to make y'all do that tonight for homework, writing out all these letters. But we can go ahead and find the difference here. And we know that once we find the difference, we're going to put that in the denominator. So whenever the numerator is bigger than the denominator, where is our exponent going to go, Anna Grace?
In the bottom.
In the bottom of the fraction, which is called, what is the bottom of the fraction called, Hannah?
The
The denominator. Very good. So go ahead and let's look at our practice problems. Excuse me, back on page 125, we're kind of flipping pages a little bit. Let's look at number 2. So I have y to the 5th over y to the 6th. Everybody can look up here with me and get that written down on your paper, or just follow along in your book. So we can look at this and immediately know, what do we immediately know, Hannah?
We have division.
We have division, and can we do our division?
Yes, because we have the same basis.
Okay, we have the same basis. And let's look at our exponents. This is what we just talked about over there. What do we know because of which one is greater, Anna Grace? We're going to have a fraction, that's right. It's not just going to be a whole number. That's a great way to put it, Anna Grace. And why are we going to have a fraction?
Because you can't take, you'd have a negative number.
Yeah, we have a negative number. That's exactly right. So we're going to go ahead and we're going to write this out the long way. We're going to have 5 y's, and my y's just keep getting bigger as I go down. 1, 2, 3, 4, 5, and let's go ahead. 1, 2, 3, 4, 5, 6. And go ahead and cancel them on your papers with me. Does everybody have 1 left over in their denominator? I see lots of heads shaking. Yes, they do. So we're going to write that. Remember our understood 1. We don't have to write it, but I'm just doing it so you don't forget about it. We have 1 over y. But why don't I go ahead and write 1 to the y to the 1st power? Why don't I do that, Hannah?
Because it's understood.
Because it's understood. That's not necessary. We don't need to do that. Go ahead and do number 3 and number 5 practice problems at your desk. And we will work those together in just a moment. Once you're done, you can look up towards the board. Okay, let's go ahead and start on number 3. So we know we have a fraction bar, so we know we're dividing, and we do have the same bases. So we're not going to write these out for sake of time. But Anna Grace, tell me, what did you get on b squared divided by b to the fourth power?
1 over b squared.
1 over b, almost wrote a b squared. Does everybody agree with that? Is that what you got, Hannah? And like Anna Grace said over there, whenever we have the larger exponent in the denominator, we know that we're going to have a fraction. So tell me, Hannah, what you had on this one. We know we have division and we know we have the same basis. What did you have?
1 over m squared.
1 over m squared. Everyone agree? Shake your head. Yes. Looks good. Okay, let's go ahead and practice just a few more. If I can get you to do 13, 14, and 17. Those you don't have to write out the long way. We can just subtract them and write them like we normally would. Hannah, if you would do 13 at the board, Anna Grace, you get to do 14 at the board, and I'm going to do 17 at the board. Make sure you keep your distance while you're at the board. How's it coming at the board? Make sure we're working diligently. Okay, so I assigned you guys 13, 14, and 17. Hannah, go ahead and show us 13. Tell us what and why you had what you had.
I had b cubed over b to the fourth power, and 3 minus 4 would have given me a negative b, so I just kept it in my denominator and had 1 over it.
Very good. Anna Grace.
I had x to the 5th power over x to the 8th power, and I saw that it was division and we had the same base, so I went over, so I subtracted and got x cubed to, or 1 over x cubed.
Nicely done. That looks great. You can erase that and have a seat. I did number 17. I had m to the 5th over m to the 7th, and I know that 7 minus 5 is 2, and I knew I was going to have a fraction, so I got 1 over m squared. Great job on practicing those today. You really seem to get the hang of it. You can go and put your books away, take out those homework notebooks. Your homework will be Sharpening Skills 21 through 30, page 126. That's 21 through 30, page 126. You guys are dismissed.